All right, so now let's look at using those same properties of logarithms, right? Our product property, our quotient property, and our power property to condense expressions to a logarithm of a single quantity. All right, so now notice we're going to be doing the opposite of what we did in the last video. We're starting off with multiple logarithms, all right, and our answer should have a single logarithm, all right? We want to condense this into a single logarithm. All right, a couple things to notice here. I have two logs, and they are separated by subtraction. All right, we're definitely going to want to use the quotient property. However, before you use the quotient property or the product property, you must make sure that the coefficients in front of each of your logs is a 1 or a negative 1. All right, in this case here, the coefficient in front of this log is a 2. So we need to take care of that first, and we can take care of that by using the power property. The power property says that if we have a constant multiple in front of the log, we can bring that into the log as an exponent. In other words, this would be log base 8 minus log of x squared. Log base 8 minus log of x squared. I brought that 2 constant multiple in front of the log into the log as an exponent. Now I have two logs with the exact same base, this is log base 10 on both of them, connected by subtraction, with coefficients of 1 in front of each one. So, because they are connected by subtraction, I can use the quotient property now to rewrite these as a single logarithm. This would be log of 8 divided by x squared. Remember, subtraction turns into division, right? I take my first term, the quantity that's inside of the log, and I divide by the quantity that's in my second log. Log of 8 divided by x squared. And again, when you are condensing these, notice that your answer should always end up being a single logarithm. I only have one log here. Let's try another. Okay, 3 log base 5 of x minus 2 log base 5 of y minus 4 log base 5 of z. Now, again, always take care of any constant multiples in front of your logs first. Notice that we can use the power property for each one of these to bring that constant multiple into the log as a power. This would be log base 5 of x cubed minus log base 5 of y squared minus log base 5 of z raised to the fourth power. Now, let's go one step at a time. Let's look at these first two logs. They are connected by subtraction. Subtraction of separate logs can be written as a single logarithm with a quotient. This would be log of 5, log base 5 of x cubed divided by y squared. Log base 5 of x cubed divided by y squared minus log base 5 of z to the fourth power. Now again, I have two logarithms connected by subtraction. I can use the quotient property once again. All right, this would give me log base 5 of x cubed divided by y squared divided by z to the fourth. Now notice that dividing by z to the fourth would be the same as multiplying by 1 over z to the fourth, and so that z to the fourth actually ends up in the denominator of this fraction to get rid of the complex fraction. All right, so we end up with log base 5 of x cubed divided by y squared z to the fourth as our final answer. Again, notice a single logarithm. All right, a couple more examples here. Use the properties of logarithms to condense the expression to a logarithm of a single quantity. We have 4 times ln z plus ln z plus 5 minus 2 ln z minus 5. Now, there are a couple different routes that you could go in this particular problem. All right, one method here is to start from the inside out. Think about order of operations, parentheses, right? Work from the inside out with parentheses. Here, inside of this log, we have two natural logs connected by addition. That means we can use the product property to condense that into a single logarithm. Also, with this logarithm here on the right, this natural log, we have a constant multiple in front of the log. We can use the power property and bring that constant multiple up as an exponent. This gives us 4 times the natural log of z squared plus 5z. Notice that's what I get when I multiply z times z plus 5. That's z squared plus 5z minus the natural log of z minus 5 quantity squared. All right, two logs now connected by subtraction. We definitely want to use the quotient property, but before we use the quotient property, we need to make any of the coefficients 1 or negative 1. So what do we need to do with this for? Use the power property first to bring that into the exponent. We have the natural log of z squared plus 5z raised to the fourth power minus the natural log of z minus 5 quantity squared. Now I have two logs connected by subtraction. We can use our quotient property to condense this into a single logarithm, the natural log of z squared plus 5z raised to the fourth power divided by z minus 5 quantity squared. Okay, now one thing to make note of is that your properties of algebra still apply. So if you wanted to, all right, you could solve this problem by distributing this 4 into each one of these terms first. 4 ln z plus 4 ln z plus 5, all right, and then use the power property for each of the individual terms. That would also bring you to the correct answer. So algebra, you can still do algebra. Don't forget about that. The rules of algebra still apply even though we are dealing with logarithms. All right, let's take a look at one more here. So 1/3 times the entire quantity, 2 ln x plus 3, plus ln x minus ln x squared minus 1. All of that in big brackets. So again, I'm just going to stick with the order of operations, starting with parentheses, work from the inside out. Let's see if we can't combine some logarithms inside of this big bracket. Well, in order to do that, I must first use the power property. The power property with this 2. I can bring that into the exponent. All right, this gives me 1/2 times the natural log of x plus 3 squared plus ln x minus ln x squared minus 1. All right, so let's go one step at a time. Let's combine these first two logs. These first two logs are connected by addition. I can rewrite that as the product inside of a single log. That would be 1/3 times the entire quantity ln x times x plus 3 squared. Whoa. ln x times x plus 3 quantity squared minus the natural log of x squared minus 1. So we can continue to condense inside of this bracket. All right, I have a difference, subtraction of two separate logs. Same base, these are both log base e, so I can rewrite them, combine them into a single logarithm using the quotient property. This gives me 1/3 times the natural log of x times x plus 1 squared divided by x squared minus 1. And our final step in this case is going to be to use the power property. Notice this is 1/3 times all of that. So what does the power property tell me I can do with a constant multiple in front of a log? Bring it into the log as an exponent. I can raise everything that I see here to the 1/3 power, giving us our final answer, the natural log of the entire quantity x times x plus 3 squared over x squared minus 1, all which is raised to the 1/3 power. And if you wanted to, yes, the 1/3 power, that's the same thing as taking a cubed root. If you wanted to write it as a cubed root of all of that, that would be perfectly fine. However, I think that fractional exponents are much easier to work with, and they certainly will be down the road as you continue into calculus. All right, that's the end of chapter 3.3. If you have any questions, make sure you reach out.